Welcome back to The Explainer. Today, we're jumping straight into a high-stakes, ticking clock well control scenario. I want you to picture this. You're working on a rig and suddenly, total blackout. The engines die, the lights cut out. But 10,000 feet below you, a bubble of high-pressure gas, a kick, has entered the wellbore and is racing straight up toward the surface. You've got a massive problem on your hands, and you need to seal it, right now. So you've got this high-pressure kick screaming up the hole, and you have to shut the well in. But what exactly is in the way? I mean, at that exact moment, the space passing through your safety valves could be filled with standard drill pipe. Or maybe it's a much fatter drill collar. It could even be a thin wire line, barely the thickness of your finger. Or, hey, there might be absolutely nothing at all in the way, just an open hole. Now, most industrial safety valves, they can only handle one specific shape or diameter. And right now, you definitely don't have the luxury of swapping out valves. And that brings us to the hero of today's explainer. Because there is one valve on the rig that handles every single one of those scenarios. It seals around any pipe or no pipe at all. We're talking about the Annular Blowout Preventer, which is, hands down, the single most forgiving safety device on the entire rig. It doesn't ask questions, it just closes. Now, before we look at the hardware, let's quickly frame up the physical space it actually protects, the annulus. You likely know this is that vital ring-shaped pathway around a pipe inside a wellbore. You've got the outside of the drill pipe forming the inner wall and the raw rock or steel casing forming the outer wall. During normal operations, drilling mud goes down the inside of the pipe and comes right back up this annulus. But in an emergency, that exact same ring-shaped space becomes the superhighway for a dangerous gas kick to reach the surface. If you don't block the annulus, the well blows out. Plain and simple. Okay, so let's get into the actual gear. The Annular Blowout Preventer is your absolute first line of defense. It's this massive dome steel valve sitting right at the very top of the blowout preventer stack. And it is specifically engineered to squeeze fully shut and form an impenetrable pressure seal right across that annular space. Basically, it holds the door shut on the well. What's really fascinating is that the mechanics of this massive unit are surprisingly elegant. First off, hydraulic fluid enters the steel body from below. Then that fluid forces a massive piston upward. And finally, as that piston rises, it squeezes this thick, heavy donut of steel-reinforced rubber, which we call the packing element, pushing it upward and inward. And because that thick rubber literally has nowhere else to go inside that heavy steel housing, it's forced inward. It shrinks its aperture exactly like a camera iris to choke off the well. And thanks to that specific motion, it forms a perfectly tight seal around whatever happens to be passing through the center at that exact second. If you want a perfectly simple analogy to visualize this, just think of a rubber grommets, or even easier, your own fist. Close your fist around a thin pencil. It seals. Close it around a much thicker marker pen. Still seals. Close it with absolutely nothing inside, and your fingers simply meet in the middle to form a complete seal. That immense flexibility is the Annular Preventer's entire value proposition. But, unlike your hand, this thing operates on a scale that's honestly kind of hard to fathom. See, there are steel ribs molded directly inside this rubber packing element that prevent it from extruding under pressure. That gives it the unimaginable strength to hold back up to 10,000 psi from the well below. To put that into perspective, 10,000 psi is enough pressure to lift an entire car off the ground using an area the size of a standard postage stamp. It's just wild. All right, Section 1. The layered BOP stack. Let's see how this builds into the broader well control system, because the Annular Preventer never, ever works alone. The blowout preventer stack relies on this aviation-style layered redundancy. You never trust a single seal to hold a well on its own. The crew closes the top annular valve first to gain control fast, precisely because it adapts to anything. Below that, they'll close the pipe rams for a hard, long-term seal. And down at the very bottom, the shear rams. That is the absolute last resort. It literally cuts clean through the steel drill pipe to seal the bore, sacrificing an incredibly expensive drill string just to save the well. So the crucial takeaway here is the functional difference between those layers. Pipe rams have these fixed, semicircular steel cutouts. They are sized perfectly for one exact pipe diameter, and if the wrong pipe is in the hole, they simply cannot seal. The annular, on the other hand, asks absolutely no questions. It offers a totally flexible seal that closes on whatever's passing through it right at that critical moment. Moving on to Section 2, storing the emergency power. So let's jump back to our ticking clock scenario from the beginning. What actually happens if the rig loses all power and you only have about 30 seconds to slam these massive valves shut? Well, that's exactly where the accumulator steps in. Think of the accumulator as the rig's emergency battery, except it stores immense physical pressure instead of electricity. It's basically a rack of heavy steel bottles sitting on the deck, holding hydraulic fluid that's squeezed super tight by precharged nitrogen gas. Even in a total blackout, this system has the stored energy ready to go. A really great way to think about how the accumulator works is to picture a drawn crossbow. It takes a long, slow, deliberate effort to pump the hydraulic fluid into the bottles against that nitrogen. You're cranking the pressure up over several minutes. But when the driller actually pulls the lever, the release of that compressed energy is instant and violent. It shoves the fluid out to slam the stack shut in under 30 seconds. Because it's so vital, API regulations dictate the accumulator has to store enough usable fluid to close the entire stack, all the rams plus the annular, and still retain a buffer of 200 psi. But look, there's a fatal trap here, a silent nitrogen leak. If the nitrogen gas leaks out of the bladders over time, your gauge might still read full pressure because it's packed with liquid. But without the gas to actually push it, you just have useless, stagnant fluid. The well simply will not close. Which brings us to Section 3, the rubber's fatal flaw. Because despite all this brilliant engineering, we have to acknowledge a hard truth. So these annulars are typically rated in working pressure classes of 5K, 10K, or 15K psi. But the hydraulic closing pressure, the force actually pushing on the piston to shut the valve, is deliberately regulated way down to around 1500 psi. Why? So the rubber element isn't completely overcrushed. This lower pressure is absolutely crucial because it allows crews to perform stripping, which is where they carefully move drill pipe up or down through the closed annular valve while still holding back the well's pressure. But honestly, that incredible flexibility comes at a pretty severe cost, and the failure mode is the rubber itself. The backing element is a consumable with a service life. It's not permanent. If you overclose it on an empty hole, cycle it repeatedly, or strip pipe too fast, that rubber element will violently shred. And a torn annular gives you absolutely no warning. It holds perfectly right up until the second it doesn't. So, let's quickly test your understanding of all this with a scenario. If you've got a thin wire line in the hole, so not a standard drill pipe, but something much, much smaller, and a dangerous kick suddenly occurs, which valve on the BOP stack are you going to close? Do you reach for the annular or the pipe ram? You go for the annular every single time. A pipe ram would just blindly close its steel cutouts around that thin wire, leaving an empty gap where the well could easily blow out. But the annular preventer, acting like that camera iris, just keeps squeezing inward, adapting its shape until it finds a tight grip around that wire line, sealing the annulus completely. And this just reveals the stunning reality of the entire well control mechanism. You've got this multi-million-dollar, 10,000 psi failsafe made of impenetrable steel, yet it ultimately relies entirely on a piece of reinforced rubber, a consumable piece of rubber that is literally designed to wear out, holding back total catastrophe perfectly until it tears. It leaves us with a truly provocative thought about extreme industrial safety. When the stakes are this absolute and lives are quite literally on the line, are you trusting the impenetrable steel you can see? Or are you just assuming that a consumable piece of rubber hidden deep inside is ready for the absolute worst? Thanks for joining us for this explainer. We'll see you next time.